In this video, we're going to look at the while loop, which is another way to repeat blocks of code. Let's start with a review of for loops. We have an initial value for a loop variable, then a condition, which will make the loop repeat, and then an update. Right? That's all in the header. However, they don't execute one after another every time, right? This part only happens once. After the condition is true, the body of the loop executes, everything that's between the braces. The update happens after the body of the loop, and then we return to the condition. So it just prints a message, right, some number of times. Change this number, recompile, see it a different number of times. Right, so the while loop is a more general form of loop that requires you to do the setup before you reach the loop header. So I could say something like this: int looper is 0. And then the keyword is while. And the only thing that goes in the parenthesis is the condition. And immediately followed by the braces for the body of the loop, which is a good time to compile. And within the body of the loop, the update will always be last. So whatever you want to have happen in the body of the loop will come first. Blank line between. Make it a little clearer what's going on. And we can change this right to anything we want. Like so. So you see the while loop can do anything a for loop can do. However, there are some times when it's awkward to set things up as a for loop. Consider, for example, a situation where I don't know how many times I'm going to have to repeat a task. I don't want the user to have to tell me how many numbers there are ahead of time. I just say add them up. Then we have, in this case, we have to have a special agreed upon signal for when we're finished. What you do is you repeat as long as you have not found the special value, and it could be a range too. Right, so, for example, we want to write a program that adds things up without asking how many there are to begin with, and so we will need a sum. We'll start at 0, and then we start off by asking for our first number. So far, so good. We've just got the first value. But now we keep going as long as the value is not our special value that signals that we're at the end. So if val is not the sentinel, well, that's braces. I've written some statements here, so we want to. Okay, so compile there. Now, what we have to do is process this value and then get the next one. All right, so the processing in this case is just adding it into this running total. We'll say sum plus equals val. All right, that's the one that we got on this line. But now we have to get the next one. All right, so this is going to be very similar, except I don't have to declare the value anymore. And it's not first value anymore, it's the next value. What's the first value? 3, 4. Maybe that's all I have. Sum is 7. Notice how the sentinel is not included in the result. That's very important, in these kinds of problems, because you want to have a variable that's kind of serving two roles. Right? It's your input variable, and right, you're watching for a special value that you don't want to include in your result. So this will handle any number of values. What's the first value? 2, 3, 4, and maybe that's it. Sum is 9. Notice the negative 999 is not included. Let's say what again? 10, 15, and 5, and maybe that's it. Sum is 30. Consider another example in, say, organizing a tournament, and each team has to have at least 7, but no more than 11 players. Right, and you have to get to sign up for the tournament. You have to say how many people are on your team, but within those ranges. But you have to reject inputs that are not valid. And so we do something like this. We get the first input, number on the team. Keyboard.next int. And we haven't prompted for this yet. We should do that first. And now the condition is, well, if the number on the team is lower than that or bigger than that. So we have while num on team less than least, or num on team greater than most. All right, now, if that's the case, we can't accept that answer. We have to ask again, and means this number isn't any good. So we have to get another one. So we'll repeat the input. And of course, we already have this variable, so I don't need to say the type again. But perhaps I want to say why I'm repeating the input. And so we add another message here. Say, right, so before I go to ask again, I say, well, that was invalid. I can't use that. And then we do another input. So now this is the end of the loop. So after this statement, control will go back and check the condition again. And if number on team is still less than least or greater than most, right, it's going to say no. It's going to repeat. And we get another one. Let's see how that works. How many on your team? 6. Invalid output. How many on your team? 12. Invalid output. Oh, how many on your team? 12. Okay, and then it stops. All right. Now this is a little bare bones, right? Because it's not really giving user much information. Maybe we put some a little more guidance in there. Okay, 6. Invalid. Okay, between 7. Okay, and we're missing a space at the end. 6. No, 12. 9. 9's okay. And usually when you have something like this, you want to repeat the final input. All right. 24, 15, 19, about 8. The team will have 8 players. Another way to use while loops is to, say, count years of growth needed to reach a specific target. We've seen a for loop. Right? If you know the number of years you're going to say grow a population and the rate, right, you can find out what the population will be after so many periods of growth. Well, if you don't know the number of growth periods, but you have, say, a target, well, then you can find out the number of years. Right? So here we'd have, just repeat, while the population is less than the desired population. Notice the prompt did not come back. It's not outputting anything, but the program is still executing. Right? Otherwise, we would see the system prompt come back. What's happening now is an infinite loop because nothing about either variable in the condition is changing. Right, so that's very important to realize with while loops is that something inside the loop has to change. Right, so you get into a situation like this, you can generally press Control-C to stop your program so that you can try again. So with input screening, number on team is in the condition and it also changes in the loop. Right? With the sentinel loop, the value that you're collecting to add up is also in the condition. In just a converted for loop, the update to the loop variable is the last thing that happens in the loop. So if nothing changes in the loop, or nothing about any variables in the condition change, you can have an infinite loop. All right, so we compute the growth and then add the growth. It doesn't have to be every variable, right? The desired population is going to stay the same, but this will change every time we go through. So every time this is true, right, we're going to calculate a number and add that to it. All right, so we expect that it'll happen at some point. But there's one last thing going on here. We have to say, all right, we have to count that year. If we want to know how many times we had to go through this, we'll say years plus equals 1. And then we output okay, 75.6. Okay, so maybe you'd round that or truncate it, add whatever would be appropriate. But we had to go through this 14 times at 3% to start at 50 and end at something at least 75. Notice we went over a little bit. That's to be expected. You're not going to land right on it unless it's particularly great. If I raise the rate, it should take fewer years. And yeah, sure, 9 years, but go a little bit higher over it. If I lower the rate, it should take more years. 21 years. So there's some uses, applications for the while loop.